Okay, here we go. Continuing on. Let's find theta where u is equal to the vector with components 2, -3, 1, and v has components 1, -2, 1. All right, so there's a lot of formulas to memorize in Calculus 3. The best way to do it is just have a stack of flashcards by your bed and look at them, once before you go to bed at night. This is one of them. On one side of the flashcard, you should have cosine theta. On the other side, you should have u dot v divided by the magnitude u, magnitude v. Yes?
What's the I on the v vector?
The I on the v vector.
The first number?
It's just a 1, yeah. Here, I think there's just a smudge on it. I can fix that. 1, okay. So here's what instead of memorizing steps, you don't do that, but you do need to memorize formulas. Let the formulas be your guide, right? What does this formula tell you need? What magnitude of u and v and the dot product, right? So let's start with the dot product. So what's u dot v? Let me use blue. So what's u dot v? So just do the multiplication. The work I want to see is the multiplications, the actual, the multiplications of corresponding components. Show me that. You don't have to show me 2 times 1, just show me 2, right? So for the first one, 2 times 1 is 2. And then what do we end up doing? Adding 6. And then adding 1. Everybody with me? And what does that turn out to be? 9. And then let's find the magnitude of u. Big old square root. And what goes underneath the square root? What do you end up adding together when you square the components? So for u, it's 4, right? It's 2 squared plus 9 plus 1. So I would like to see this, 4 plus 9 plus 1. And then what's that? Root 14. And then magnitude v. What's that going to be? Square root of 1 plus 4 plus 1. So root 6. Okay. Okay, let's put it together over here. Cosine of theta then is equal to what? Well, what goes on top out of what we just found? 9. The 9. So 9 over root 14 times root 6. Not a very elegant way to write it, though, right? So, okay, a little scratch work. Root 14 times root 6 is the same as root 14 times 6, right? There's a factor of 4 in there, isn't there? 2 times, let's see, 14 is 2 times 7, 2 times 3. So you're going to have a 4 times 7 times 3, 21. So 2 root 21 on the bottom. Everybody buy that? So cosine of theta is equal to 9 over 2 root 21. Leave it like that. I don't care if you rationalize. Leave it like that. That's a good way to write it. Now, that's cosine of theta, right? We need theta, don't we? So theta, you could take the cosine inverse of both sides. You don't have to worry about it spitting out the wrong number because theta is either in the first quadrant or the second quadrant, and it's going to spit out the cosine inverse. That's where it's defined. It's going to spit out the right angle here. So you could just take the cosine inverse of 9 divided by 2 root 21. So I'm getting approximately 0.19 radians.